Hi everybody, I'm Ian Cunningham from Vector GB. Welcome to this episode of Engineering the Jigsaw, Foundation episode number 6. What is AutoZAR? Today, of course, we're going to talk about what AutoZAR can mean, and let's just say right now, it can mean a lot of different stuff depending on the context. So we're going to try to cover a number of these different cases with you today. We may skip a couple of them. Before we go too far, we really should point out that both the word AutoZAR and the logo that you see here are both registered trademarks that we have got permission to use in this episode. And in this episode, we're really going to build on the concepts that we first introduced in episode F2, what is an ECU. So you really do need to have watched that before you watch this episode. You might also get some benefit from having watched episode F3, networks in vehicles, but you could probably watch that after this episode and it maybe just help you understand some of the examples that we'll cover. Now, our main focus today is going to be on something that is called the AutoZAR Classic Platform, and this relates to ECUs nearly always. For HCPs, there's something else which is typically more relevant, which is called the AutoZAR Adaptive Platform, which we just aren't going to have time for in this episode, but we will come back to in the future. Enough of the future, the past. Once upon a time, there was the situation that ECUs were getting more and more important to vehicle manufacturers, being able to put the functions into vehicles that they wanted to be able to deliver to the people buying those vehicles. And it was realized that actually only some of the aspects related to ECU software were standardized. So for example, there were standards that defined how CAN works and how diagnostic protocols and calibration protocols worked, and a few other things, but not everything. So of course what this meant is the vehicle manufacturers had to specify everything else themselves, which is a lot of effort. And on the side of the suppliers, they kind of had the opposite end of the problem, which is that because they wanted to supply many different manufacturers, they had to cope with many similar but different specifications, which is, again, a lot of effort. And also, on the manufacturer side, there was no easy way for manufacturers to be able to add new functions into ECUs or even to move existing functions between ECUs. And this had the result that new ECUs had to keep being added to vehicles every time a new function was going to be added in. All really, things you want to try to avoid. So vehicle manufacturers and suppliers agreed that a standardized specification in relation to ECU software was both a good idea and necessary. And the result of this agreement was AutoZAR. So AutoZAR, or the Automotive Open System Architecture, and it is an abbreviation, so it should always be capitalized all the way through. There was a development partnership founded by a group of vehicle manufacturers and major suppliers to develop a standardized set of specifications for ECU software. So it wasn't just the manufacturers, it wasn't just the suppliers, it was both working together. Sometimes people talk about the AutoZAR Consortium, but technically it's the development partnership, AutoZAR development partnership. So AutoZAR is often used to refer to the development partnership, and I will do that right now. AutoZAR first released specifications for software in 2005, and the first project using AutoZAR was in 2006. So I'm recording this episode in 2021, so 15 years after that first project. So AutoZAR, in terms of concepts and a lot of the content is very mature. And AutoZAR, of course, can mean software that matches the specifications. For example, AutoZAR Classic 4.3, or it can mean other things. So as well as standardizing the ECU software, AUTOSAR defined a process, or more technically, a methodology, and they also defined file formats that are to be used by software tools that have different roles, different jobs within that process. And AUTOSAR, therefore, can also mean the process, the tools, or the file formats that are used in that process by those tools. And it's worth mentioning just very quickly, the format is AUTOSAR XML, or ARXML for short. And ARXML can be used to transport many, many different things. So it's very important to know what kind of ARXML you have. Just saying I have an ARXML file is as meaningless as going up to somebody and saying, I have a book. It really doesn't tell them anything. So you really need to understand what the type of ARXML file is that you have to be able to explain to them what you really have with them. And if we think about the AUTOSAR software and how this was standardized, then we've talked in the past about how we can have an application that interacts with the RTE and then basic software and a microcontroller. And what AUTOSAR did, they standardized ECU software by dividing it into these layers. And then we can think there's some sections within those layers. Sometimes people talk about stacks within AUTOSAR, but really the whole AUTOSAR basic software is a stack together. And then within there's modules. And essentially each of the areas within the stack were subdivided down until we got to a point where we had a layer of an individual module, well-defined responsibilities and well-defined interactions between the modules. So if you know any software engineering terminology, you may have heard of separation of concerns. This is separation of concerns in action in AUTOSAR. And in total, talked about lots of little modules. There are over 100 different modules specified for the AUTOSAR Classic platform. And if you actually look into the specifications, there's over 21,000 pages of specification in the AUTOSAR 4.3 specification release. So these are huge amounts of documentation. Since 4.3, we've had 4.4, which is also sometimes referred to as 19-11. We've just had the 20-11. So the versioning has changed. It used to be this kind of major dot minor thing. Now we have a year and month version numbering. And as well as the Classic platform, there's an additional set of specifications for different versions of the AUTOSAR Adaptive platform. And really important, because we don't want to have just the Classic platform or just the Adaptive platform in a vehicle, there's also something called the Foundation specification, AUTOSAR Foundation specification. And this ensures that AUTOSAR Classic and AUTOSAR Adaptive platforms are able to work together in the same vehicle and interoperate. So it's a really crucial part of the standardization effort. If we think about the methodology, well, this is really simplified, really simplified in many different ways. So let's think about a system where we're only going to have 4 functions. So I'm going to have an engine control set of functions. So I've got speed sensing, I've got accelerator pedal sensing, and I've got obviously the power control itself, the engine. And then I also want to have traction control. So I'm going to detect when wheels are spinning, and I'm going to ask the engine power control software to reduce the power temporarily. So I define all these functions across the whole vehicle or system and how they might interact. So my engine speed sensing will send the engine speed to the engine power control. So I have feedback. I have traction control that will occasionally send a reduced power request. And accelerator pedal sensing, of course, will be sending the accelerator pedal position to engine power control to let that do its job. So what we then have to do is describe each software component that is needed for each function. And importantly, it's very, very unusual that it's a one-to-one relationship. So there'll be many software components within an individual function, usually. And of course, many, many, many functions, not only 4, as I've shown here on this slide. What we then want to do is we want to take these software components and allocate them to the ECUs we want to put into our vehicle. And there's a number of ways we might choose to do this, governed by different constraints about where things are located and how we want them to work. And we will then, once we allocate the software components to the ECUs, we'll describe how networks join them together. And this is called the system description process. So we take our software components, allocate them to ECUs, we add in the networks. We're then able to describe all the communication that is needed to take data from one ECU to another to be able to make sure that the software is still able to share the data that it needs to be able to share to work. This is the system description. Once we've done that, then for each ECU, we can extract the description of the software and the communication needed. And we can give that to the supplier that we've chosen for that ECU. Or we can, of course, develop the ECU ourselves. That's completely open. Once the ECU extract is available, and this is a type of ARXML, and the software component description is a kind of ARXML, we can perform ECU configuration tasks, and that's another type of ARXML. And of course, we can also write the application, and typically this is done with either C code or a model-based implementation tooling. And not really important, this is where the portability aspect comes in. We don't have to have just one person or one company writing the application. Because we're able to describe how the software components are sharing data, anybody can write a software application and give it to the person responsible for an ECU for them to integrate it in. Because each software component only ever communicates with the RTE. So even if all these 3 software components here only talk with each other, they won't actually directly communicate. All data sharing is done via the RTE, and this gives us the ability to have portable applications because the RTE looks the same to a software component no matter where it is in the vehicle, no matter which ECU it's in. So as a summary, AUTOSAR can mean a lot of really different things, and it really depends on the context. So there's the AUTOSAR Development Partnership, that is the source of the AUTOSAR software specifications, and there are different platforms within AUTOSAR. There's the adaptive platform and the classic platform, and Vector provides basic software according to both the classic and the adaptive platform. So we have products classic MicroZAR and adaptive MicroZAR. The AUTOSAR Development Partnership has also defined a process and many different file types, which are all ARXML to be used within that process. And tools used in the process are often called AUTOSAR tools. And of course, Vector provides many different AUTOSAR tools. If you'd like to know more, then firstly, we provide free e-learning on the classic platform from AUTOSAR, and also, of course, we provide detailed technical training to ECU developers and people doing the system description process. There is, of course, also the AUTOSAR Development Partnership website where you can download all those thousands and thousands of pages of specifications if you feel the need to. Of course, most people don't want to have to deal with the thousands and thousands of specifications, and they come to a specialist vendor such as Vector, and we have a whole solution around both the AUTOSAR Classic platform and the adaptive platform. For the Classic platform, we cover everything from initial concept development through implementation and test to validation. So all the system design, software component description and development, basic software, the configuration tools, the software and hardware for testing ECUs, you name it, Vector almost certainly provides it. If you want to find out more about HCPs and the AUTOSAR adaptive platform, then please keep an eye out for our episodes that will cover these and other topics coming up in the near future. That's really everything for today. So thank you very much for joining us for this episode. Please join us again for our upcoming episodes. In the meantime, if you have any questions on the content of this episode or any other one, or if you've got an idea for a topic that you'd like us to cover in an episode, then please email us with our special email address, engineering.jigsaw@vector.com. Thank you very much for joining us. Bye.